Right now, 50,000 light-years away, a dead star is spinning in the dark, and it is the single most magnetic object in the entire known universe. It is smaller than the city you live in. It has been dead for thousands of years, and in one flicker, lasting a tenth of a second, it let out more energy than our sun will produce in the next 100,000 years. That pulse crossed the whole galaxy. It still reached Earth. It brushed the top of our atmosphere as it passed by, and instruments on the ground felt it happen. So, what kind of corpse can do that? It's called a magnetar, and here is what almost nobody tells you. A magnetar is only one of the things a star can leave behind when it dies. There are 7 of them. 7 kinds of corpse, each one stranger than the last. Some of them crush, some of them vanish. And the final one on this list, physicists still can't agree it's even real. So let's do something most space videos never do. Let's walk through all of them in order, from the quietest body in the graveyard to the one that breaks the rules. Treat it like a crime scene because that's what it is. Every star that has ever existed is, in the end, a body waiting to be identified. The only question is what gets left behind when the lights go out. And the answer comes down to a single thing: how much the star weighed while it was alive. It's a tug of war. While a star is alive, the fire in its core pushes outward, and that outward push is the only thing holding back its own crushing gravity. The instant the fuel runs out, gravity wins. And how hard gravity slams the door, what it leaves on the floor when it's done, depends entirely on how heavier the star was to begin with. Start small, and you get something almost peaceful. Start big, and you get a monster. We're going to start small, and we're going to end with something that might not exist at all. Keep one number in the back of your mind the whole way down. The heavier the star, the worse the body. Watch how fast peaceful turns into nightmare. The first body is the most common one in the universe. It's called a white dwarf, and there's a very good chance our own sun is going to become one. When a star like the sun runs out of fuel, it does not go out with a bang. It sheds its outer layers, drifting them off into space like a snake shedding skin, and what is left behind is the core. Just the core. Take everything the sun is, all of that mass, and crush it down until it is the size of the Earth. That's a white dwarf. About 97% of all the stars in the universe end up exactly like this, which means this quiet little ember is, by far, the most common way for a star to die. For our own sun, that day is coming, though not for a long time yet. In roughly 5 billion years, it will swell into a red giant, big enough to swallow the inner planets, then throw off its outer shell as a glowing cloud of gas, one of the most beautiful sights in the sky. It's confusingly called a planetary nebula, even though it has nothing to do with planets. And once the cloud clears, what is left in the middle is the white dwarf our sun was always destined to become. So how dense is it? Here is the number that does the work. Scoop out a single teaspoon of white dwarf material, set it on your kitchen table, and it would weigh 5.5 tons. 1 spoonful, heavier than a car. There is a hard ceiling on how big one can get. Push a white dwarf past about 1.4 times the mass of the sun, and it cannot hold itself up anymore. We even have a famous one to point at. Sirius B, the small companion to the brightest star in our night sky, is a white dwarf sitting right there in our own neighborhood. But assuming it stays under that mass limit, it just sits there. No fuel, no fire, slowly cooling for billions and billions of years, leaking the last of its warmth into the dark. And as it cools, something quietly beautiful happens inside it. The carbon in its core begins to lock together and crystallize. The corpse turns slowly into a single cosmic crystal the size of a planet. But here is the strange part. We have never actually seen the end of that process. Not because it is hidden, because the universe is too young. The next stage simply has not had time to happen yet. Because if you let a white dwarf cool all the way down, every last degree of heat bled out into space, it becomes the second body on our list. A black dwarf. And remember that crystal we said was forming in the core? Now picture it finished, cold, dead, pitch black against a black sky, a diamond the size of a world, so dark you could drift right past it and never know it was there. But no one has ever seen one. Right now, there is not a single black dwarf anywhere in the universe. Cooling a white dwarf all the way down to black takes something like 1,000 trillion years. Our universe is only about 13.8 billion years old, so the entire cosmos will have to grow old and run down and go dark, every star gone out, every galaxy gone cold, before the very first black dwarf ever finishes forming. These are corpses waiting on a future that hasn't arrived yet. And there's one last thing attached to them, and I want to be completely clear. This is a prediction, not something anyone has ever seen. In that frozen, far-off dark, the most massive black dwarfs might not stay silent forever. After a span of time so long you would write it as a 1 followed by 1,100 zeros, they could finally detonate one by one. The last explosions the universe will ever produce, flaring in an empty sky with nothing left alive anywhere to watch them go out. That's the gentle path. That's what waits for a small, ordinary star. The big stars do not die gently. They collapse, and what they leave behind is where this stops being peaceful. When a star much heavier than the sun runs out of fuel, its core caves in. Not slowly. In about 1 second, an object the size of the Earth collapses down to the size of a city. The outer shell of the star rebounds off that collapsing core and blows itself apart in a supernova, an explosion bright enough to outshine an entire galaxy. A wave of ghostly particles floods out first, carrying away almost all of the energy in the first few seconds. And what's left, sitting in the middle of all that wreckage, is the third body on our list. One of the most extreme objects that exists anywhere, a neutron star. Picture it, 1 to 2 times the mass of the sun, packed into a ball about 20 kilometers across. You could drive from one side to the other in 15 minutes. The gravity is so violent that protons and electrons get crushed together into pure neutrons. The entire object turned into a single, city-sized atomic core. And the density? Forget the teaspoon for a second. A single sugar cube of neutron star material would weigh about as much as Mount Everest. Now, stand on the surface. The gravity there is roughly 200 billion times stronger than the gravity holding you in your chair right now. You would not fall over. You would be pulled flat, smeared across the surface, in a layer thinner than a sheet of paper, in less time than it takes to blink. The gravity is so intense it actually bends the light around the star, which means you can see part of the far side of it curving into view, as if the back of the object were leaking around the edges. And here's something to sit with for a moment. That violent supernova, the one that forged this neutron star, is also the kind of death that cooked the heavier elements now scattered through your own body. The iron in your blood, the calcium in your bones, All of it was made in the dying convulsions of massive stars like this one, then flung across space to eventually become you. In the most literal sense, you are walking around built out of what these deaths left behind. And if a neutron star were just a little denser, it would not be a neutron star at all. It would cross the line into something far darker, and we will get there. But first, some of these crushed cores do something so regular, so precise, that for a while the people who found it genuinely wondered if someone was trying to send us a message. Because some neutron stars spin. And I do not mean slowly. Take that same crushed core and set it turning, and you get the fourth body on our list. A pulsar. It is not a different kind of corpse. It is a neutron star, the exact same body we just described, spun up to a speed that does not sound possible. The fastest one we have ever found turns 716 times every single second. Sit with that. A ball heavier than the sun, the width of a city, whipping around more than 700 times a second. As it spins, it fires a beam of energy out of its magnetic poles, and that beam sweeps across space like the light from a lighthouse. Every time it points at Earth, we catch a pulse. Tick, tick, tick. And these pulses are so steady that some pulsars keep better time than the atomic clocks we build in our most advanced laboratories. They are, quite literally, the most accurate clocks in the universe, and we didn't build them. A dead star did. When the very first one was found, back in the 1960s, the signal was so perfectly, impossibly regular that the astronomers gave it a nickname before they understood what it was. They labeled it LGM-1. It stood for Little Green Men. For a short electric while, a beam from a dead star looked exactly like a signal from a civilization trying to reach us. It wasn't. It was just physics, ticking. But here's the part that gets under your skin. These corpses are so steady you could set a clock by one for 1,000 years and never catch it slipping. And yet, slowly, over millions of years, every single one is winding down, the spin bleeding away, the ticking growing fainter and farther apart until the lighthouse finally goes dark for good. Even the most perfect clock in the universe is quietly running out. But spin is not the most dangerous thing one of these corpses can do. Take that exact same neutron star, and instead of spinning it up, crank its magnetism to the absolute edge of what the laws of physics will allow. That is when you get the monster we opened with. This is the fifth body, the Magnetar. And this is the one the whole story has been climbing toward. It is a neutron star, the same crushed core, but with a magnetic field so strong it sits at the top of everything we have ever measured, anywhere. Roughly 1,000 trillion times stronger than the magnetic field of the Earth. To understand what a number like that actually means, you don't need a physics degree. You need a credit card. If a Magnetar sat halfway between here and the moon, its magnetic field would wipe the strip clean off every credit card on the planet. And honestly, the credit cards would be the least of your worries. Get within about 1,000 kilometers of one, and the field is strong enough to pull the atoms in your body apart, one at a time, stretching them into thin needles until you simply stop being matter as you understand it. These things are rare. We've only ever confirmed a few dozen of them, partly because they don't last. A Magnetar stays this violent for only around 10,000 years before its field fades and it settles back into an ordinary neutron star. But while it's active, it is terrifying. The crushing pressure inside cracks the solid crust of the star, and when the crust snaps, the whole thing convulses in a starquake, releasing a burst of energy in a single blinding flash. Now go back to the one we started with, the body catalogued as SGR-1806-20. When that Magnetar flared, this single dead object, sitting on the far side of the galaxy, let go of more energy in 1/10 of a second than the sun gives off in 100,000 years. For that instant, it was the brightest thing in the sky beyond our own solar system. The pulse traveled 50,000 light years, and it still arrived with enough force to disturb the upper edge of Earth's atmosphere. A dead star, reaching across the entire galaxy to touch us. If you didn't know things like this were out there, do yourself a favor and subscribe, because the list isn't finished, and the last two are even harder to believe. And while you're at it, leave a comment and tell me which of these 7 you'd least want to find in our neighborhood, because a Magnetar is the most violent corpse a star can leave behind. But it is not the most extreme, because some stars don't leave behind a body you can see at all. The 6th body is the one almost everyone has heard of, and it's the only one on this list that hides itself completely. A stellar black hole. When a star is truly massive, more than about 20 times the weight of the sun, the collapse does not stop at a neutron star. There is a line somewhere around 2 to 3 times the mass of the sun, where even the leftover core crushed into a neutron star cannot hold itself up anymore. Push past that line, and nothing in known physics can stop the fall. The core just keeps collapsing, down and down, smaller and smaller, until it vanishes behind a one-way door we call the event horizon. Anything that crosses that door, including light itself, never comes back out. Now, let's clear up a myth, because it matters. A black hole is not a cosmic vacuum cleaner roaming space and sucking everything in. If you replaced our sun with a black hole of the exact same mass, the Earth would not get pulled in at all. It would just keep orbiting in the cold and the dark, exactly as it does now. A black hole only traps what gets too close inside that point of no return. But cross the line, and the rules turn savage. The difference in gravity between your head and your feet becomes so extreme that you would be stretched out into a long, thin strand of atoms, a process scientists have actually named spaghettification. And time itself turns against you at that edge. To anyone watching from a safe distance, you would never actually be seen to fall in. You would appear to slow down and freeze and hang there at the lip of the horizon, your image stretching and dimming over thousands of years, while from your own point of view, you were already long gone. The first one we ever found, a body called Cygnus X1, gave itself away because of the superheated gas screaming as it spiraled in. So the body is still there. It still has mass. Its gravity still grips everything around it. But you cannot see it because it has erased itself from view. The star that made it is gone, and what replaced it is a hole in space that gives nothing back. So that should be the end of the line. White dwarf, neutron star, black hole, quiet, crushing, invisible. Except there is a gap on the chart, sitting right between the neutron star and the black hole, where there might be one more kind of corpse. And no one has ever proven it is there. This is the 7th body, and it's the reason this list ends with a question mark instead of a full stop. It is called a quark star. Here is the idea. When a neutron star gets pushed almost to the point of becoming a black hole, but not quite, the pressure inside might get so extreme that the neutrons themselves break apart, down into the smaller pieces they are built from, called quarks. The result would be something even denser than a neutron star, a body made of pure quark matter, holding the line, stopping just barely short of total collapse. Some physicists think that matter, packed that tight, might even be stable, a new and far stranger form of matter than anything that exists in the world around you. Hold a piece of it in your hand, if you somehow could, and it would be unlike any substance you have ever touched. The problem is, we have never found one. Not for certain. About 20 years ago, two objects in the sky looked wrong, too small, too cold to be ordinary neutron stars. And for a moment it looked like we finally had one in our sights. But the evidence slipped through our fingers, and the case is still open today. So here is where that leaves us. The laws of physics say this thing should be out there somewhere, a corpse denser than a neutron star, made of matter crushed further than matter is ever supposed to go. And in all the sky we have ever searched, we have never once pointed at a single one and said, for certain, there it is. And that is the eeriest thing in this whole graveyard. The strangest body of the seven isn't the one that flattens you or the one that swallows the light. It's the one we still cannot prove is even real. So there's your list. 7 bodies. The white dwarf, the slow ember our own sun is heading toward. The black dwarf, the corpse too young to exist yet, waiting on a universe that hasn't grown old enough to make it. The neutron star, a mountain folded into a sugar cube. The pulsar, the lighthouse that fooled us into thinking we'd finally found company. The magnetar, the most magnetic thing in all of creation, reaching across the galaxy to touch us. The black hole, the body that erased itself from the universe. And the Quark star, the one physics keeps a seat open for and has never once seen. Every star you have ever looked up at and admired is going to become one of these, including the one we orbit. Someday in the impossibly distant future, the sun itself will be a body on this list. If you want to keep staring into the parts of the universe most people would rather look away from, subscribe, and I'll keep finding them for you. And tell me, down in the comments, out of all 7, which one keeps you up at night? Because the truth about the night sky is simpler and darker than it looks. Most of what's out there isn't alive, it's just what got left behind.